we want feedback loops. We want then a way to learn from experts. And lastly, we want a way to plan things by understanding language. So these are the three things that allow us to achieve autonomy. So I wanted to do a quick presentation because robotics is so visual. Like, I can talk to you about robots, but wouldn't it be more fun to actually watch robots do really cool things? So I'm just gonna do a really quick talk, just almost like a literature review of what I think is like the coolest research work being done in robotics. And then tie it back into, well, how can we take really cutting edge work and actually apply them to real world problems, like some of the things that we're working here at Medra. So I wanna talk about autonomy and the future of AI-powered robotics. And the thing I think you should know about me more than any of my credentials, or what my thesis for my PhD was, is that I love robots. I love robotics. I grew up watching and reading sci-fi. I love WALL-E, and I'm really, really excited to be nerding out with you all about robotics today. So I hope you guys are excited too. And I mean, as a total nerd and geek about robots, there's a lot of things to be excited about these days, right? Like, there are robots that are building our cars. There are robots that drive our cars for us. There are robots helping us with deliveries in the Amazon warehouses, and also robots that will actually make those deliveries to our houses. So there are all these really cool advances right now in robotics, and there's a lot of things to feel stoked about. But at the same time, there seems to still be a bit of a gap, right? Like, we look at robots in a factory that is doing really cool, interesting things, but that's still different from this vision and dream of autonomy, right? Like a WALL-E who can remember to put up his tracks when he goes at home so it doesn't dirty his trailer, and then he's wants to watch his favorite movie on his little iPod. And that's really the dream you and I have about robotics, not just robots that can build our cars. So where's that gap? And so I want to talk about a difference between what I see as automation and what I see as autonomy. So automation is really specialized robots, and then you have engineers who program it and spend hours and hours and hours of getting the robot to do exactly what you want to do, and then the robots will do very specialized tasks. But what we think about autonomy is, what if we can have a general purpose robot? Maybe that's a humanoid robot, maybe that's a robotic arm that has human-like dexterity, and then it can do anything, right? It can do general purpose things and be autonomous. So what's that missing gap there, right? And I think the answer is AI. And I want to talk about what are the components to AI that actually will make autonomy happen. So components to AI enable general purpose objects. Is it foundation models? No, I'm not going to talk about foundation models today. Foundation models could be a way we can reach the autonomy, but I actually want to talk about components. And those components could be achieved through foundation models, but foundation models might not be the only way we can achieve it. So I want to talk about three things, the three components that I think is necessary to reach autonomy. One is feedback loops, or in academia we call it perception action loop. Learning from experts, and lastly, understanding of language. So I'm going to try to go through this really fast, and again, this is going to be kind of a quick literature review of what I see are the coolest things that are happening that are able to exemplify these three components. So okay, feedback loop. Here is a robot that can actually see things. There's a camera pointing at the whiteboard, and as you draw things, it wipes the whiteboard, right? There's feedback happening. It's perceiving, and then it's acting, right? So you want robots that actually can perceive the world and act on it. That's what feedback loop is. Now, feedback loop can be really low level. In this case, this robot is just trying to track where this object is, so it's just following it as it goes. Or it could be something more high level, like a reward. So you give it a reward, and there's some way to predict a reward, and people who have done robotics research might recognize this as like a very simplified way of explaining reinforcement learning. And so you give the robot a reward every time it does the task, right? And so that's how we train this robot to wipe the whiteboard. Whenever it wiped the whiteboard clean, we gave it a reward. So it just learned by getting the feedback of what's good. Well, the thing with feedback is it can be really difficult to program. So something like this wiping task, we actually trained for like 2 weeks straight in simulation, or what amounts to real world 2 weeks, and just for something wiping, and then we then transferred it to the real robot. And so that seems like a long time, anytime you want to do a new task, to have to train it and create a simulation model. But what if you could, instead of having to figure out what the right reward is and program it, you could just teach the robot what to do, just like how we learn a lot of our new skills. So learning from demonstration, so this is some pretty cool work out of Stanford, where they built a system to demonstrate to the robot how to do something. It's just you're controlling a robot that then controls another set of robots. And then the robots are able to learn how to do these tasks. And this is just pure imitation learning or supervised learning. And the robot's able to learn some pretty complex tasks. And again, without any having to program any very specialized rewards. It's just pure demonstration, and it's able to learn how to do these things. And it doesn't have to be from really complex systems where you have to build this really cool robotic setup. You could potentially learn demonstration from videos itself. And there are also some really cool works where you can use special gloves, or you can have special grippers that can do these demonstrations. So if we could just teach a robot, kind of similar to how I learn things. Like when I want to learn how to change a wheel on my car, I just watch a YouTube video. That would be a great way to teach a robot how to do a new task. Now, there are limits to this kind of demonstration learning from experts, imitation learning, which is that, you want to teach a robot a task, but maybe if you want to teach a robot how to cook, it's like, well, first you want to cook an egg, then you want to cook some rice, and then you want to serve it together. But sometimes you're like, I just want my egg by itself. You don't want to demonstrate this long task of cooking an egg and cooking rice. You kind of want to have components separated and then stream them together. So you need some way of planning how to string these different skills that you're learning together. And that's where language is actually a great way for robots and for us to plan and learn. And there's been some really exciting work. This is out of Google DeepMind, where you can actually give language instructions and the robot can just be able to plan out how to do certain tasks. That'd be great to use that as a way to do planning. And part of that could be LLMs that is able to understand the language. But it doesn't have to be. You could also think about planning from symbolic language, which is what this work is trying to do. There's no LLMs here. This is just symbolic language, task and motion planning, and it's able to do some really complex things. No LLMs involved, and plan out these tasks. So I want to then, again, say what these three components are. We want feedback loops. We want then a way to learn from experts. And lastly, we want a way to plan things by understanding language. So these are the three things that allow us to achieve autonomy. So thanks, everyone. And yeah.